Good morning students. Welcome to Organic Natural Products class. This is Chandravati. In this class you are learning about synthesis of azadirachtin. So we are discussing about synthesis of azadirachtin in this class. This is the structure of azadirachtin. So we are preparing this molecule. In the previous class, we are discussed about the constitution of azadirachtin. The major structure of azadirachtin is constituted by using spectral data. So by using this spectral data, we are confirmed the structure. We are confirmed this structure for azadirachtin. So our next aim to prepare azadirachtin which contains this structure, and then we are compared all properties of synthesized azadirachtin and naturally occurred azadirachtin. If these properties are identical, then the structure of azadirachtin was confirmed. Synthesis of azadirachtin. So synthesis of azadirachtin starts from 6-bromo-5-methyl to norbornanone. Synthesis of azadirachtin starts from 6-bromo-5-methyl to bornanone. To this ring, decalane derivative is added to prepare azadirachtin. So let us start the synthesis. First of all, the 6-bromo-5-methyl 2-bornanone is treated with dihydroxymethane. On treatment with dihydroxymethane, nucleophilic substitution is occurred. The bromine atom in the substrate is replaced by hydroxy group from reagent in the form of nucleophile. So as a result, we get 6-hydroxy-5-methyl to norbornanone. 6-hydroxy-5-methyl to norbornanone. This compound contains a free hydroxy group. So this hydroxy group is reactive functional group. So we must protect this hydroxy group to go for further reactions. So to protect this hydroxy group, this compound is treated with benzoyl chloride. Benzoyl chloride. On treatment with benzoyl chloride, it loses a HCl molecule, that is the hydrogen from hydroxy group and the chlorine atom from benzoyl group are lost in the form of hydrogen chloride, and the hydroxy group is protected in the form of benzoyl group. This compound on treatment with perbenzoic acid, it undergo Baeyer-Villiger oxidation because it is a cyclic ketone. It is a cyclic ketone. Cyclic ketones on treatment with perbenzoic acid, a oxygen atom from peracid is introduced into the cyclic ketone. The oxygen atom is inserted at alpha to the carbonyl group. So this is a well-known reaction as Baeyer-Villiger oxidation. So on treatment with perbenzoic acid, we get a lactone ring, which on treatment with molybdenum tetroxide MoO4, it is an oxidizing agent and it especially oxidizes the alpha carbon of carbonyl group. So the molybdenum tetroxide oxidizes the carbon alpha to the ketonic group. So this carbon can be converted into alcoholic group. So CH2 group at alpha to the carbonyl carbon can be converted into CHOH. So again we get another hydroxy group which is more reactive. So we have to protect this hydroxy group. So we are treated this substrate with tertiary butyl diacetyl chloride. So on reaction with this compound, the hydrogen on or hydroxy group and the chlorine from TBDCSCl loses in the form of hydrochloric acid and the hydroxy group is protected in the form of TBDS. After oxidation with molybdenum tetroxide, this carbon contains another hydrogen. That means this carbon contains another hydrogen. So on treatment with sodamide, which acts as a strong base, abstracts the alpha hydrogen on alpha carbon to carbonyl group. As a result, a carbanion is formed. It is treated with allyl bromide. As a result, the allyl group is substituted at alpha carbon to the carbonyl group. This compound on treatment with ozone. Here one step is missed, that is ozonolysis. After substitution of allyl group, the compound is treated with ozone for ozonolysis. As a result, the double bond is oxidized to form a ketone. So this C double bond C can be converted into C double bond O on treatment with ozonolysis. This is missed here. So let us note it. After ozonolysis, the compound is treated with sodium borohydride. After ozonolysis, we get a diketonic compound, this one on treatment with sodium borohydride, selectively this ketonic group is reduced to hydroxy group. So this ketonic group can be converted into hydroxy group. This compound on treatment with base undergo cyclization to form a hydroxy compound. So after treatment with base, it abstracts the hydrogen on this hydroxy group and forms a oxoanion. This oxoanion, the electron rich center, attacks on electron deficient carbonyl carbon. As a result, a new single bond is formed between oxygen and carbon. Between this oxygen and carbon. As a result, the carbonyl oxygen can be converted into hydroxy group. Again we get hydroxy group. So we must protect this hydroxy group first. So for the protection purpose, this compound is treated with methyl iodide. As a result, the hydrogen on oxygen atom is replaced by methyl group from methyl iodide. This compound on hydrolysis, especially selective hydrolysis, the benzoyl protected hydroxy group is hydrolyzed to form free hydroxy group. So we are doing selective hydrolysis. Hence the other protected hydroxy groups are not hydrolyzed. Only this hydroxy group is hydrolyzed to form hydroxy group, free hydroxy group, which is oxidized with chromic oxide. So, the free hydroxy group on treatment with chromium oxide can be converted into ketone. So, on oxidation, the hydroxy group at this carbon can be converted into ketonic form. This ketonic compound is refluxed with decalene derivative and a base sodium amide. So, to form a carbon-carbon single bond between these two compounds. So, this ketone is refluxed with decalene derivative with sodamide. The NH2 minus ion from NaNH2 acts as a base and abstracts acidic proton from decalene derivative. So, the amide ion abstracts the proton from decalene derivative. So, this is the proton abstracted by NH2 minus ion. As a result, a carbon ion is generated at this carbon. This carbon ion attacks on electron deficient carbonyl carbon and forms a carbon-carbon new single bond. Okay. So, as a result, the carbonyl group on this compound converted into hydroxy group. So, a new carbon-carbon single bond is formed between these two compounds. This compound is dehydrated by using dehydrating agents. So, after dehydration, it loses a water molecule. This water molecule is removed from this, the hydrogen and the hydroxy group. These two groups are removed in the form of H2O molecule. As a result, we get a new carbon-carbon double bond at here. This on treatment with perbenzoic acid, the double bond formed newly is epoxidized to form epoxide ring. So, on treatment with perbenzoic acid, the double bond is epoxidized, which on treatment with hydrolysis in diethyl ether, the protected methoxy group is hydrolyzed to form free hydroxy group. So, especially hydrolysis in diethyl ether hydrolyzes the methoxy group to form free hydroxy group. Then it is treated which on dehydration, it loses a water molecule. So, the free hydroxy group at this carbon and the hydrogen adjacent to the carbon is removed in the form of water molecule and forms a new carbon-carbon double bond. This epoxide ring continues throughout the synthesis. So, you must remember that the epoxide ring must be written at this position for final synthesis. Here we are missing this epoxide ring in the remaining structures. So you keep writing this epoxide ring on every structure. Okay. Next, this compound on acidic hydrolysis in diethyl ether, the phenyl group is hydrolyzed to form two free hydroxy groups. So, on hydrolysis in acidic medium in diethyl ether solvent, we get two free hydroxy groups. Next step is esterification to introduce ester group in the proper ester group in the azadirachtin. Thus, when we do selective esterification at C1 with tiglic acid, the tiglic acid moiety is substituted at C1 position. So, on selective esterification with tiglic acid, this hydroxy group is esterificated with tiglic acid group, and further selective acylation introduces acetoxy group at this position. So, this hydroxy group is esterification with tiglic acid, and this hydroxy group is acylated. So, almost we done the total synthesis of azadirachtin. So, there is two steps remaining. One is the removal of protecting groups from oxygen. So, for this purpose, this substrate is hydrolyzed in presence of potassium dicarbonate and quaternary ammonium fluoride. On hydrolysis with quaternary ammonium fluoride and potassium carbonate, the benzoyl groups and TBDS, tertiary butyl diacetyl groups, are hydrolyzed to form free hydroxy groups. Then this compound is reduced with sodium borohydride. When this compound is treated with sodium borohydride, the ketonic group on decalene ring can be converted into hydroxy group. So, on treatment with sodium borohydride, the ketonic group in the decalene ring is reduced to hydroxy group. So, we get the azadirachtin finally. So, this is the synthesis of azadirachtin.